All right. Tēnā koutou katoa. No auto tahi ho, ko Adrian Clark toku ingoa. Kanuiti mihi kia koutou katoa. No reira, tēnā koutou, tēnā tātou katoa. Good evening, everyone. My name is Adrian Clark. Thank you for coming tonight for my lecture on what does AI mean for the entertainment industries. I hope you will enjoy it. Before we get started, though, I've been told there are some housekeeping details that I need to give. The first and apparently the most important is the location of the bathrooms. So if you need to use the bathroom, if you head out back the way you came and then go down the stairs, there are bathrooms just on your right. In the event of a fire alarm, please follow the UC staff. So you'll notice there are people round in red shirts. They will be able to give you instructions and follow them to the evacuation points, and please remain as a group. We have some nice facilities here, but if there is a fire, let's have a look at them afterwards. In the unlikely event of an earthquake, stay where you are, take shelter, do not evacuate unless you're instructed to by UC staff, and please follow the instructions of the UC staff. Should evacuation be necessary, the assembly point once we exit the theatre building is just outside. You would have come in that way. Any questions about our housekeeping? No? Everyone looks content. All right, let's move on. So, this talk was something I agreed to do a little while ago, and hopefully I've spent a lot of time sort of going back and forth on it, what I should cover, what would be interesting, what would be suitable for the group, because I was told that to think of this like a TED talk to non-academic staff, to general public. I know immediately just from listening into some of the conversations here, there are probably a lot of people in this room who know more about this topic than I do, but hopefully there might be something you'll learn, or if nothing else, hopefully it'll be slightly entertaining. Now, what I'm going to cover is essentially generative AI in 3 acts. The first act is going to be about how generative AI works. So it's not going to get into too much technical detail. I sort of targeted this as if I wanted to teach generative AI to my parents. So don't be too put off by that, hopefully. Then we're going to look at what generative AI can do. So once we understand how it works, we're going to see some actual examples of generative AI. And then finally, we'll reach the kind of topic of this, what does AI mean for the entertainment industries? And this was actually probably the hardest part of the topic for me to write, or the hardest part of the talk for me to write, because I'm really just kind of guessing. We're still very early days in this, but I will talk about a few of the implications, a few of the challenges, and kind of where I think or hope things will end up. There will be some live demos. You'll notice this example up in the top corner. Anytime that pops up on screen, I should be giving an example. If I forget, please let me know. In true Murphy's Law fashion, I've already had a pretty significant technical glitch in that I was going to have my laptop here to do live demos, and that has decided it's not going to work. So I'll be doing live demos and my presentation off the same computer, so bear with me. It's probably going to be a disaster, but hopefully it'll be entertaining for you watching me flounder about up on stage. And there's going to be some audience participation as well. So if you would like, I'll give everyone a couple of minutes. You're welcome to scan the QR code on there with your phone. You can take out your camera. When it comes up, you can do a little tick on it, and we'll open a website called Slido, where you can basically just put in some ideas. And we're going to take those ideas and put them through generative AI, because I'm not a magician. I'm not here to trick anyone. I actually want to show you how generative AI actually works in real life. In addition to that, I'll also at various points in time be asking your questions to make sure you're paying attention and staying awake. So yeah, there'll be audience participation in it. I made the horrible decision of checking the Facebook comments on this talk and wanted to clarify a few things that this talk is not about. This is not a tutorial on how to build your own generative AI. My background is in computer science. I do have a PhD in computer science, but I predate generative AI by quite a significant margin, and there are a lot of people here, well, possibly in this room, but certainly at this university, who could give you a much better detail about it. We're going to talk about it at a very high level. I am not an AI researcher. This is not going to be a complete overview of all generative AI. This has been a really challenging talk to write, because every time I've gotten to a point where I think I'm pretty close to being finished, someone will send me a link and they're like, have you seen this? No, okay, so I have to go back and modify it. And eventually I got to the point where I just had to tell people, stop sending me information. I get it, generative AI is moving incredibly fast. and I can't keep up with it all. So we're going to see a few sort of examples, but it is not going to be an exhaustive overview of it. This is not a legal, ethical, political, or philosophical position for or against generative AI. I have opinions. I am not qualified or smart enough to discuss it in this forum, but I'm sure a lot of people are coming here with their own opinions as well. I'm just going to talk about generative AI. You will hear, because I am opinionated sometimes, I will probably inject some of my own biases into the talk, but I'm not here to change anyone's mind on anything. I'm just here to talk about it and hopefully get you to think a little bit more about your own feelings towards this. There was a surprising amount of people who were asked, who made comments about the Terminator, Skynet, and all these sorts of things. I don't think generative AI is at the point yet where it is going to be the downfall of humanity. And even if it was, I am not the person you want to run to stop the AI apocalypse. So just getting that out of the way now, we're going to be sticking within AI in the generative industry. Okay, so you might be wondering, well, okay, you've said you are not a AI researcher. I had another point in here which I deleted because I couldn't word it right, but I'm also not an entertainment industry expert. The two things that this talk are about are probably not my two biggest areas of expertise. So why the hell am I giving this talk? I'll let you in on a little secret. Ever since I said that I would give this talk, I've asked myself the same question every day. So I'm going to tell you a little bit about myself so that you will understand where I'm coming from, understand the context, and hopefully that way when we get to the Q&A at the end, you'll be like, I'm not going to ask him a question about that because he won't know. So who am I to give this talk? This is me. I'm about 8 years old before time ravaged me. I was a cute kid. You will notice that I'm in a towel. I had literally just gotten back from the pool, and the first thing I did was jump on my Commodore 64 to play Garfield. This drove my parents crazy. You know, there was several times I was told, get off the bloody computer. No one's ever going to pay you to sit around playing video games all day. Fair enough. Here is me last year winning the UCSA, University of Canterbury Students Association Lecturer of the Ward for my job teaching game design and development, where I get paid to play my students' game. Took me 31 years, but I proved my parents wrong. It may not be 100% accurate. My memory of my childhood is a bit hazy, possibly from spending too many times playing computer games. My parents may be watching this on Facebook, so love you, Mum and Dad. Thank you for supporting me, even though you may not necessarily have agreed to it. But then the question might be, for those of you who are perhaps a little bit older and thinking entertainment industry like films and TV, what is he talking about with games? Well, games are part of the entertainment industry, and in fact, and this may be controversial, games are now the largest part of the entertainment industry based on revenues. This data is a little bit old now, but games are now bigger than the film and television industry. Some numbers have them larger than, in fact, television and film combined. This is not a talk about games, but I'm just trying to justify my reason for giving this talk. The other thing to think about games are no longer a hobby dedicated for antisocial, pimply teenage boys playing in their parents' basement. My parents didn't even have a basement. The rest of it's fairly accurate though. So actually, who am I beyond this? Well, I am an associate professor and I'm the acting head of the School of Product Design, which is one of the newest schools and newer departments in Canterbury. I am also the Faculty of Engineering academic lead for the Bachelor of Digital Screen program, which we are in Otakaro, which is I guess our home base for the digital screen program. Our students studying digital screen are learning about being professionals in the entertainment industry. So the digital screen degree has 6 majors: animation, cinematic arts or filmmaking, game arts, game development, screen sound, and screenwriting. So although I wouldn't consider myself necessarily an expert, I work with a lot of people who are experts, so I can bask in their knowledge and glory. I was not always an academic. I returned to the university in 2019. I founded a company after finishing my PhD based around kind of almost a precursor to generative AI. It was computer vision based augmented reality. My PhD was in computer vision, and we'll see a little clip about Quiver Vision. Hopefully it'll, again, give you a little bit of an idea of where I come from and why generative AI is something that's quite interesting to me. I have a PhD and a BSc with honours in computer science. I am from a technical background, not an arts background, although I've found myself throughout my career and more adult life drifting more from technology, probably into the more creative side of tech, simply because I just couldn't keep up with the math. And my PhD thesis, for anyone who cares, which is probably no one, was called OPERA, the Optical Flow, Perspective Invariant Registration Augmentation and Other Improvements for Natural Feature Registration. Quite a mouthful. You don't have to remember it because AI made it irrelevant anyway. So you might get a little bit of an idea of my feelings towards AI here, but it's okay. We can be very pragmatic about it. So my background is in computer vision. And computer vision, depending on your definition, is a subdiscipline of AI. The AI we're going to see tonight is not like what my PhD thesis looked like. It was math, and more math, and more math, and just linear algebra, effectively. Don't read it. It is super dull, and it has now been completely made irrelevant. But it did allow me to build this company called Quiver Vision. So Quiver Vision was based on my PhD thesis and the research that I did as part of it. And basically what it allowed us to do was recognize and identify coloring in pages that children had colored. So nothing special or magical about these coloring in pages. They're just straight out of a printer, coloring in pencils, crayons, whatever you want. And then it would recognize these pages and extract their colors and textures and generate 3D content off that. So here is an incredibly cheesy video that we used as part of our marketing thing. But you can see children coloring it, and it comes to life in beautiful, amazing 3D. Right, enough of that. So yeah, the app, you can download the app on your iPhone or Android device. It still exists. The company still exists. But I'm still a shareholder. I'm still an advisor, but I'm no longer part of the company. That wasn't what I would consider actual AI, and I'm sure if there are any computer scientists in the room, they would feel the same way. But I have actually done a little bit in the space. Here is some work one of my former PhD students, then former employees, and now colleagues at the School of Product Design, and I did as part of his PhD thesis, doing hand segmentation using AI. So you can see it's trying to, the colors represent the various joints in your fingers. You can see it works terribly. But it was actually good enough for us to get more or less a buyout offer from a billion-dollar company. Spoiler alert, that didn't happen, which is why I'm here talking to you and not relaxing on a company. That is a topic for another talk I give, which is how to fail at creating a successful tech company. Sorry, let me mute that. But I did actually do some work in generative AI before leaving the company and running back to academia with my tail between my legs because startup and entrepreneurship is really hard. So this is an AI technique called neural style transfer, which essentially, it's not a great video, I apologize for that, but essentially you color in your page and then you can select various artists' work and it will regenerate the image you drew in the style of those artists. So we had things like Edvard Munch's The Scream, we had Starry Night by Van Gogh and a bunch of other things, and you could have it. Just not a very good video, but you can play with it. It's available on there. So I mentioned tonight we're going to do some live demos. We're going to and do some audience participation. If you haven't already, you can start posting some ideas. I have two people here, two former students and one current student of mine, Angeline, wave Angeline, and Bree. I pulled them into this last minute, so that's why they look very shocked, but they are here to help me. They are what are known as prompt engineers tonight. They have never done this before, so let's see how this goes. What is prompt engineering? Prompt engineering is the process of structuring an instruction, that's a really awkward way of wording that, that can be interpreted and understood by a generative AI model. So it's basically somebody who knows how to talk to an AI to actually get it to do what they want it to do. I'm going to do some live demos myself, which are probably going to go horrendously badly, Bree and Angeline have the advantage that they have a little bit more time to get this stuff right, not in front of a live studio audience. So they're going to be looking at all those ideas you suggest, and they're going to be creating AI content to show what's actually possible over the scope of 45 minutes. Why do I have them? Getting a good result from generative AI is really slow and frustrating. I mean, okay, when I say slow, it's like 30-second maybe turnaround. But I actually tried to get AI to help me with this presentation a bit. This was a brand new presentation for me, so I had to put together a lot of content, and it was so frustrating that I basically gave up and just did it by hand, other than a few images and stuff like that. In fact, the image that you saw at the start and the image you might have seen on Facebook was created by Midjourney, which is an image generative AI. I spent 40 minutes trying to get that image before rage quitting and getting someone else to do it because I couldn't get it to look right. I also don't trust generative AI. I haven't been warned necessarily, but this is a public event, clearly with the public. It is being broadcast live on the internet. I don't want generative AI to be creating anything that I'm not comfortable with. So Angeline and Bree have the advantage of anything like inappropriate. I know you're going to make fun of me, and that's fine. I'm going to try and do my best to not end up displaying anything that's going to offend or upset anyone. And that's why Angeline and Bree are here. Right, okay, let's get into Act 1, how generative AI works. How are we doing for time? Right. So, a simple overview of AI. Here's the audience participation part. Oh, no, it's coming in a couple of slides, sorry. First, we're going to start with some definitions so that we're all on the same page of what AI is. I have written these slides from my background as a computer vision person. This is how I understand things. When I teach, I usually come from my own place and try and get everyone to where I am. For those of you who have experience in AI, you may look at this and you're like, why is he doing it this way? He's teaching it all wrong. This is my lecture, be quiet. So we're going to start using AI to classify objects. That is what my background was. You saw it with Quiver. We recognized the pages, we identified them, and we did stuff with them. This isn't meant to be a particularly accurate or even factual history or description, but it hopefully will get us all on the same page so you're not leaving here going like, oh my God, he's working with Skynet. These are just simple tools. This is a classification that I saw that I'm using. Different people will define all these things in different ways. But when I talk about artificial intelligence, we're basically talking about intelligent machines which are capable of doing things that previously would have been kind of the jobs of humans. Machine learning is a subdiscipline of artificial intelligence, which is looking at pattern recognition and data. So if we give it a bunch of data, it can automatically find trends and patterns, and then it can apply that to new observations. You can say, as we'll see in a minute, here's some data, tell me what this is, where does it fit in? And then we have a subdiscipline of that as well called deep learning, which uses neural networks. You might have heard of neural networks. And what makes deep learning different from machine learning is deep learning finds patterns in unstructured data. So images, text, things which don't follow rules. It's able to drill down and actually find semantics and meaning in this unstructured data. So let's start with a complicated example. I hope you've all brought your thinking caps. Here is our first classification example. Does anyone want to tell me what is different between the objects in category A and the objects in category B? The colors. I heard someone very quietly mumble because they didn't want me to point them out. Yes, you could say everything in category A is blue and everything in category B is not blue. Well done. Gold star. There is a way that we can represent this in a slightly more scientific, slightly more sort of computer science or AI-focused way. Which is we basically have something which looks like this, where we put a shape in, and it's going to go out into one of category A or category B, and we've said the color should be, if it's blue, go into category A, if it's not blue, go into category B. Obviously, this is ridiculously simple. You know, I didn't hear a roaring thing of everyone saying color, but that's probably because no one wants me to pick them out and say, tell me the answer. But this is something we should probably all be able to do. The reality is this is actually what one of these systems would look like. We'd have one or more inputs going in which are weighted. We'd have some sort of function which combines those. We'd have an activation function which determines whether or not it should trigger an output. All of these are represented by numbers and various patterns and stuff that we're not going to go into. But even if we just think about color, color is actually really difficult to classify. Who remembers this picture? Yeah? I'm hearing some moans. How many people, can I just get a show of hands, how many people see a white and blue dress? Okay, nobody now, but everyone in 2015 did. Yeah, in fact, when I was going over my slides with my wife, I showed her an early copy a few days ago, and then I showed her yesterday, and she's like, you changed that picture. I said, no, I didn't. She's like, it was a white and gold dress before. Yeah, so this was a huge thing for those of you who are too young to remember. 2015, Wikipedia, the dress. It was a big enough phenomenon that it's just called the dress. But the fact of the matter is, for those of you who don't remember, this image went crazy. Like, this was a simple time. People were absolutely flabbergasted by the existence of this dress that some people saw as white and gold and some people saw as blue and black. And I, at various points in time, have seen it in different colors, and it's all to do with the way our eyes are reacting to light and color at the time. And I found this really nice image which sort of illustrates how it can be both a blue and black and a white and gold dress depending on the scene and the environment and the colors that you're experiencing at the time. So even with a simple thing like color, it's actually not that simple. In fact, a little secret, one of the things I tried to do as part of Quiver, which I failed miserably at, was getting it to classify colors. And I still cannot get over the fact that something so simple I couldn't implement in 7 years. So this is actually what is actually happening in one of these AI classifiers. Here is a face detector. We can see in those first layers, it's very much abstract shapes, it's lines, it's edges. Then we sort of build onto those and we combine two lines and suddenly it looks like an eye or a nose or whatever. And we build up and we get into faces. So for the computer scientists, AI researchers in the audience, you'll look at this and you say, yeah, that's right. Everything else he's talking about is rubbish. So it is based on some science anyway. Okay, back to our example, the simple AI classifier example. So let's make it a little bit trickier. I'm not actually going to change the data which was in there. I'm just going to add some more data to it. There we go. So this still holds true as what we saw before, that we've still got the same shapes in A as we do in B. But clearly our original idea of what's in category A being blue and what's in category B being not blue is no longer accurate. So, okay, what could it be then? Can anyone see the pattern in this data? Mm-hmm. Brilliant. I didn't actually think anyone was going to get that. Yeah, 100%. All of the objects on the left side have an odd number of sides. All of the objects, he is not a plant. I've never seen this man before. I'm actually honestly amazed. I wouldn't have got this. I am taking a bit of a mathematical approach here in that apparently circles either have 0 sides or an infinite number of sides, depending on which of the two camps you fall into, but I'm assuming that's an even number. Yeah, so absolutely. The difference between category A and category B is the number of sides. And in fact, if we go back to our original example, we can see this still holds true. We still have an odd number of sides of objects in the left, or in category A, and an even number in category B. And this is essentially what we do with AI. We start with simple models, we pump more and more data into them, and they gradually learn trends, and then they can predict. You can imagine now if we shoved another shape into here that I'd never seen before, it'd be able to say, it's got an odd number of sides, it's got an even number of sides, put it in the right classifier. And that is what training is. Our original data is what's known as underfit, or underfitted, in that we hadn't given enough data for it to actually make an accurate guesstimate at what it is. And now it's well fitted, or hopefully it's fitted based on the data we've seen. But you could imagine the other case where we overfit, where we might say category A includes objects which are a green triangle, a blue pentagon, a blue heptagon, a blue triangle, etc., etc. And then we'd give it something else and say, oh, it's not in category A because it doesn't fit one of those. So that's a little bit of an aside, but some terminology, underfitting, overfitting, etc. And yeah, as I said, the odd and even categories still fit this. Okay, this is where I tried to get ChatGPT to help me, and it failed miserably, which is why I have such a terrible example here. So a more complicated AI classifier now, instead of just one node, we have 3, and they all put into each other. I really struggled to come up with some ideas, and I ended up with pirate, fish, robot, and flower. I'm not particularly proud of that, but never mind. I've tried to sort of classify it. So everything in the top it belongs in the sea. And if we're in the sea and we have legs, we're a pirate. If we have no legs, we're a fish. If we're not in the sea and we're made of metal, we're a robot. If we are not in the sea and not made of metal, we're a flower. This is terrible. You all could do better than this, but when I was writing these slides at 11:30 at night, I couldn't. Let's try it. What is this? It's in the sea. It has no legs. It's a fish. Brilliant. This is also in the sea. I had to, these are AI generated images. I had to ask it to generate me a swimming pirate to get it under the sea. He does have legs. We can't see them, but whatever. It's a pirate. Cool. All right, next one. It's in the sea, doesn't have legs. It's a fish. Okay, obviously this is not a model which is working. We've underfitted again. If we're going to stick with our original definitions of pirate, fish, robot, and flowers, we're going to need to do a little bit of massaging. Let's get rid of those, and we'll move those two around, and we'll say, is it humanoid? Well, kind of, but also not really. Does it wear clothes? Maybe, not really. Does it have scales? Now you'll notice that my choice of language has changed here. Before it was very binary, yes or no. Now I'm kind of like hedging my bets. I'm like, kind of, not really. And that's specifically to fit this example, because this thing is kind of humanoid, but it's not really. I mean, if you look at the top half, it is. If you look at the bottom half, it isn't. So we kind of go down both paths. Does it wear clothes? Well, it's got a hat. I don't know that I'd describe a cat as wearing clothes. There was a song about leaving your hat on, so I mean, that sort of throws that away. So it kind of wears clothes, but not really. It has scales. It's kind of hard to see there, but it does. So we might say that this is a pirate robot fish. My prompt for this was give me a robot pirate mermaid, but close enough. But really, we could sort of look at this and say, well, because we have these approximations, we're not saying it is definitely this or it is definitely that. We could say, well, it's got a 10% of a pirate because it's got a pirate hat. It's 40% robot because the top half of it is made of metal, and the rest of it's kind of a fish. So we have a probability. And in fact, this is really what AI is actually doing. So here is an example I stole off this website because they did a better job of illustrating it than I could clearly. Here is an image which we don't know what it is. Nobody knows what this is, but we run it through this structure here and it gives us some probabilities. This says it is 90% confident that this is a cat. It's 3% confident that it's a dog, and it's 1% confident that it's a bird. So this is actually what AI classifiers look like. Now, if you notice this word up the top here, it says neurons. Whoopsie daisy. And that's because these are known as neural networks. I mentioned this earlier on. They're neural networks. You would have heard neurons and neural and blah, blah, blah to refer to the brain. That's because these things are biologically inspired. So on the left here, again, I stole these images because they're better than anything I could get ChatGPT to generate. On the left here is a neural network. On the right here is a neural network, but one's a computer one, one's from actual inside your brain. And here's something that I stole from a medical paper on Alzheimer's treatment by applying ultrasound waves. I didn't read it, but they had a good image, so I stole it, which shows that your brain is really just a massive neural network, and each neuron has a nucleus and axons. And really, that's kind of an accurate map for what we see here. And in case you don't believe me, here is something that I stole off YouTube, which actually shows neurons. So these are motor neurons. These are the things which are responsible for moving your body. If you think about people like Stephen Hawking and stuff who had a motor neuron disease, he had issues with this part. So here we have a bunch of neurons which are sitting around, and I'm going to click play in a minute, and you're going to see them all start to connect and form a neural network. So we can see these little axons going out, reaching out and connecting, and they're all connecting to each other, they're communicating, and that is what's happening inside our brain. Okay, I've been talking a lot about AI classifiers. I am a computer vision researcher originally. I apologize, this is supposed to be about generative AI. Let's get to that point. So here's our terrible neural network that we had before. This takes an image and gives us some descriptors. But we don't want that. We want to give it a description and for it to generate an image. So what do? Well, we just flip it backwards. So there we go. We now have a generative AI where we put in some inputs. I want a pirate robot fish, and it reads a little bit hard backwards because we kind of say, well, a pirate kind of wears clothes and a robot doesn't really wear clothes, and a fish does have scales. And of these things, pirate robots are kind of humanoid and fish are not really. But you can sort of read it backwards. So we take our examples before, 10% robot, 10% pirate, 40% robot, 50% fish. We pass it in to those things, we pass it through, and eventually it'll generate our image. Again, a super, super simple example, but hopefully you can see from our classification, where we reverse it, we're giving our AI enough detail to generate this. Obviously, this is a massive oversimplification. We need to be able to get the AI to figure out how to combine all these things together, and that's a level of detail that I'm not prepared to go into tonight. But this is kind of the rough idea, and we're going to see some examples very soon about how this works. So I've talked a little bit about training. I was humming and hawing about where to stick the slide in because I wanted to talk about it, but I threw it at the end because I didn't want to break my flow. But we've talked about training data. We put those initial shapes into category A and category B, and we took a guess and we said it's blue, and we were wrong because it was actually odd and even sides. And that's part of learning or training AIs. And there's a whole bunch of different ways for doing them. We can do supervised learning, which is kind of what we did. We said, here are a bunch of objects, figure out what they are. Unsupervised learning, where we just give it a bunch of data and say, good luck. There is reinforcement learning, where we say, do something, and I'll tell you if you're doing a good job or a bad job. And if we tell it it's doing a good job enough times, it'll keep doing that. If we tell it to do a bad job, it'll do something else. And then there's transfer learning, where we train it to do something, and then we say, hey, you can do this thing, do that thing. You might have all experienced working like this in various jobs throughout your life, so now you know that your bosses are treating you like an AI. But the interesting thing to know here is supervised learning is the most common way of training AIs, learning from a labeled data set. But who labels the data? We need to say, this is a picture of a cat, this is a picture of a dog, this is a picture of a fish. We don't need to do that for one image, we need to do it for billions of images so that the AI can figure out what is about all these things that makes this a fish. So this is a website. This is an image that I stole and then lost the link for, so I apologize. I'm not sure. You can Google image search it and it'll probably tell you something. And they say this is where the top 5 sources for machine learning and analytics come from. This is actually where data comes from. It comes from a bunch of people who are often paid minimum wage to click on this image is of a cat, this is of a dog, and so on and so forth. So there is a New York Times article which talks about exactly this, which is where I got that image from. But the other people who label the data is you. Every time you've tried to log into your bank or anything and you've been asked to solve one of these captures, you're actually training an AI. It says, pick all the images of soup. So what are you doing? You're giving an AI some images of soup so that it can be trained on it. Now you might be thinking, hey, I never consented to that. That's somewhat unethical. Just wait until we get to Act 3. There is one last thing that I wanted to talk about before we look at some examples, and this is quite cool. This is another AI learning method. When I say cool, it's equal parts cool and terrifying, which is kind of specific to generative AI, because it's got generative in the name, generative adversarial networks. So we have our AI model that we had before, which is pumping out images of robot pirate mermaids. And we have another AI, which is called a discriminator AI. And what we do is we pit these two to the death. So the discriminator AI's job is to look at output from the generative AI and say, is this real? Like, is this actually a real image, or did an AI make it? So let's say we wanted to train our AI to generate pictures of soup. Why not? So what we do is we get our training data set that we had before, and we tell our generative AI to start making pictures of soup, and we tell our discriminator AI, here are some pictures of soup, here is another picture of soup. I'm saying soup an awful lot. Can you tell if this is a real picture or not? So here's a picture of soup that I got ChatGPT. This took me a while to get it to generate a bad picture of soup, but it gave me this eventually. And hopefully our discriminator AI would look at that and say, no, that is not a picture of soup. So what the discriminator AI does is it goes back to the generative AI and says, do a better job. So it will. It'll go and it'll try and make a better job. And it'll say, here's a picture of soup. And the discriminator AI might look at that and say, well, I mean, that's actually a bowl of fruit salad. But close enough as best I can tell, given the training data, that is a bowl of soup. And so we will now throw some more data into our discriminator AI, or we as humans will interface and say, actually, no, that's not soup. That's fruit salad. Do a better job. So next time it comes around, our discriminator AI is now a bit smarter, and our generative AI says, hey, remember that bowl of soup? And the discriminator AI will say, that's not a bowl of soup. And this goes on and on until eventually our generative AI is producing pictures of soup that the discriminator can no longer tell if it's real or not, and hopefully we as humans can no longer tell if it's real or not. And that's why I said it's really cool, but it's also terrifying. We're essentially pitting AI against each other to try and create things that can trick each other and by proxy trick people effectively, which is why AI is getting to the point that it's really hard to tell what is actually real and what isn't. One of the reasons I'm simplifying grossly. All right, the last thing we have to do, so in that image we had before, we said it's a 50% a fish, it's 40% a robot, and it's 10% a pirate. We don't want to have to try and do those and model all these weights. So the last thing we need is a way to talk to our generative AI in a way that it can understand really easily. And so what we have is what are known as transformer models, which have an encoder that basically takes our natural text and it turns it into something that AI can work with. I'm conscious that I'm taking much longer than I had planned to, so we'll move on. If anyone has any questions about transformer AIs, I can try and answer them later. But let's have a look at some AI. So text generation. So the most widely known example of generative AI is text generation. Now we're getting into the stuff that's relevant to the entertainment industries. Anything that a human can write, we can get an AI to have a crack at it now. So the most common ones are known as large language models, and ChatGPT is one of them. We'll see that word transformer in here and generative, so we know two of those three words now. Pre-trained just means it's been trained on an enormous amount of data. What's kind of interesting, thinking back, so ChatGPT is a neural network underneath it. ChatGPT has 100 billion neurons, so we got to 3, it has 100 billion, and 100 trillion synapses, which is the connections between them. Interestingly, the human brain actually only has 86 billion neurons. So ChatGPT actually has more of these individual units than the human brain does. That might scare you, and possibly it should, but at the moment it can only generate text and images and other things, so we're hopefully safe for now. But the interesting thing is ChatGPT can write text in various languages and formats, including computer code, and there's a range of different things here. So as I said, I had a bit of a technical glitch earlier. Oh, brilliant. ChatGPT-4 has locked us out. Oh, cool. So I'm going to see if we can do something. Hey, ChatGPT, can you generate a short story about a man who turns into a turkey? Oh, we've been locked out. I'm at my current user cap. Well, we might be able to do GPT 3.5. Okay. Anyway, I've got some examples we can go back to. So here is me asking ChatGPT to make up a story about Mickey Mouse on a boat. And you can see, with no further prompting, once upon a time in the sunny coastal town of Port Pleasant, Mickey Mouse, etc., etc. ChatGPT is free. We obviously didn't stress test this enough, and we've been locked out of it for tonight, but we can at least go back to some of our existing examples and have a play with it. The reason I chose Mickey Mouse here is we're going to talk a little bit later about IP copyright. But it can just generate text in English in a whole range of languages really, really easily. And really, this is kind of how large language models work underneath the scene. They've been trained on a huge amount of data with this 100 billion neural network on probabilities around, if we have a string of text, what is the most likely next word that we're going to see? So it's kind of like predictive text on your phone. You're writing it out, and you say, hey, I'm going to the, and it says supermarket, work, vet, or whatever, which is based on the text you usually do. ChatGPT is kind of doing that over billions and trillions of examples of data, so it's able to generate text really, really well. That's mixed with a bit of randomness, so it doesn't always give you the same answers over and over again, and it works one word at a time. Unfortunately, if I could, we'll see if I can do it just because I'm short on time. We'll see if I can do it through just logging in with a free account later. But what it does is one word at a time, and you'll see ChatGPT will answer you one word at a time as well. I probably won't show this video just in the interest of time because I've technically only got 5 minutes left. But there is a piece of software which was released I think the 12th of March, called Devon. So I mentioned computer programming. Devon is an AI software engineer, and the terrifying thing, as somebody who was kind of a software engineer for a while, is that Devon, when you give it an instruction it doesn't understand, it does what all good software engineers do. It goes to Google and looks up how to do it, and then it will learn from Google in real time, and it will use that to formulate its answers. So, whoops, let's go back to full screen. So yeah, we can show this during the Q&A if we need to. Moving on, image generation. So we've talked a little bit about image generation. The way they work isn't quite how we described. They use things called diffusion models, and there's a particular piece of software or technique called stable diffusion that most of them are built on. Diffusion models are actually super cool, the fact that they work at all. What they do is they take an image and they just keep on adding more and more noise to it until it becomes unrecognizable. And it learns what they look like when it adds more and more noise to it, so that then when you say, hey, give me a picture of a cat, it starts with an image of random noise, and then it works backward to make a cat out of that. And it has what's known as a noise predictor to tell it when to stop. And so we can put in different kinds of random noise as a generator and a text prompt for what we want it to end up with, and it will try and make it. And unfortunately, we're still locked out of ChatGPT, which includes DALL-E, but I do have Midjourney, but I have some examples we can see. And this is what diffusion models look like. So we have an image, and we pass it through our encoder, which is part of our transformer model. We add more and more noise to it until it's no longer recognizable. We train our AI on that, and then we work backwards gradually with a different set of noise, gradually removing it until we end up with something that looks like it. It's honestly, for me, kind of one of the most mind-boggling things. So we are locked out of ChatGPT, probably because I'm sharing my account with these two. But I have Midjourney here, which we can do a similar thing with. So let's see. I'm going to imagine a prompt. Can someone give me something to draw a picture of? Anyone? A cat. Oh, what's a tuxedo cat? Okay. Fair enough. So this is going to take a little, I should have set this into turbo mode. So this is going to take a little while to load. It's at 12%. But this is doing what we just saw. It's using stable diffusion. It started with 4 different random images, and now it's going through and it's making them more and more unrandom, and we will actually see it gradually coming into focus as it removes some of that noise off it until we're now at 75%, 85%. You can see it's becoming more and more resolved into a picture of a cat wearing a tuxedo. Beautiful. For some reason, it's chosen to make them all oil paintings, which I didn't tell it to do, but that's okay. Artistic license. But I could give it further prompts and say, please do this in a photographic style, in a cartoon style, etc., etc. We can have a little play with that during the Q&A if we have time. Video generation actually works in exactly the same way as our image generation using these diffusion models, but obviously the tricky thing is we're not generating one image, we're generating 30 plus images and stitching them all together to make a thing. But the difficulty here is we want all of the objects to remain consistent across the video. So we have Sora is one which has come out. If you're interested, have a Google of Sora. It is honestly kind of mind-blowing, but they haven't released it yet. So no one actually knows if they've just cherry-picked their examples. But there is a piece of software called Runway, which I will show you an example I made before, which is able to generate short clips. So I've generated 2 here. This one takes a few minutes, or like a couple of minutes. But I gave the prompt, a man dressed in a cardboard robot suit walking through Times Square, and this is what it generated for me. So it's kind of working. It's a man dressed in a cardboard robot suit. The people are phasing in and out of the background, which is what this temporal coherence issue is, that it's generated lots of images following this prompt, but it's not necessarily the best at saying, well, these things need to stay consistent from frame to frame. So we end up with this weird thing of people sort of popping in and out of existence. But this is an older technology than what Sora is, and so it's likely that it's only going to get better. And here's another one, a video of a dog who is also a pirate sailing on. But you can see I got a little bit hung up on this pirate thing. He's wearing a pirate's buckle, I guess, but a nice sort of example of a dog who's just sitting on a ship. Again, entirely generated by an AI just from that one prompt. Music generation is probably the last thing we'll talk about just in the interest of time. Music generation also uses transformers, such as text generators, or diffusion models such as our image generators, or a combination of these. It has similar issues to video generation around temporal coherence. You can make a song, but if a song immediately sort of jumps all over the place, it's going to sound terrible. Songs also have the additional sort of caveat that they're often structured. So most songs follow, this pattern of verse, chorus, bridge, chorus, verse, chorus, or I'm not a musician, something like that anyway. But there is a piece of software called Suno. So I'm just going to play a little song that I wrote based on a prompt. Please generate me a song in an electronic pop style about Adrian Clark delivering a lecture on generative AI. So you can see here, or maybe you can't, I'll try and make that a bit bigger, the lyrics to the song, and let's have a short listen to it. Yep.
People cheering Adrian Clark's lecture. I feel like I'm dreaming. Generative AI and entertainment collide, expanding horizons.
It's honestly kind of ridiculous, really, isn't it? That from one short sentence, it was able to generate this. And in fact, it generated a couple of examples of that. Here's the other one here, which is the same lyrics, but a slightly... Two songs, very similar, free to check out, although for commercial reasons you have to pay for it. Okay, let's blast through, otherwise I'm going to get told off for taking too long. Video games obviously are a combination of various art assets and computer code. So if ChatGPT can write computer code and Midjourney and Suno, Midjourney can make art, Suno can make music, combine it all together and you get yourself a game. Last month, Google DeepMind, which is their AI project, announced a new thing called Genie, Generative Interactive Environments, which from individual photos makes playable games. It's obviously focusing on platformers, but here is a bunch of AI-generated art that it's made games out of. And here are some from sketches and photographs and stuff. So yeah, pretty crazy. Right, Act 3, let's blast through it. So what does AI mean for the entertainment industry? You've probably already got some of your own ideas now about what can happen based on what you've seen. What does this mean? Obviously, the first thing when anyone mentions AI is we're all going to lose our jobs. And, that's probably fair enough. It's a legitimate concern. And it's one we're already seeing in many, many industries. People are going to lose their jobs. It's just a fact. I would argue that this isn't actually a fault of the AI or the technology, but it's really more around the people who would rather use an AI to do a job than pay a person to do it. The technology is only going to get better. It's only going to improve, but it's our choice as people as to whether we want to use it or not. And technology is probably not the solution to it. This is going to require either a societal or a law change. And the fact is that this isn't the first time this has happened either. Every significant technological leap has led to changes in work. For example, when the textiles industry changed from people knitting and weaving and everything, there was a bunch of unskilled laborers who formed together following this mythical person called Ned Ludd, who called themselves the Luddites. So you might have heard of Luddites. It's become a bit of a word now to describe people who fear change and who fear technological advance, because this happened with them. The AI revolution happened with them, except it was machines. And when the printing press first came out, the scribes guilds, who were basically people who got together to copy books, they had massive protests and destroyed printing presses. This is not something new. This has happened time and time again. The thing which makes AI scary is the fact that it could take everyone's jobs, really. The printing press does one job. I'm getting some stern looks, so I'm wrapping it up. And we are seeing these sort of legal changes as well. So you would have seen the WGA and the Screen Actors, so the Writers Guild and the Screen Actors Guild strikes, which they were able to win some protections around their jobs and the use of AI in their jobs. There's also concerns about IP copyright and ownership. So all of these things have been trained on massive corpuses of data, and these corpuses, they had to come from somewhere, and oftentimes they were just scraped. So you're an artist, you make a picture, someone loads it into an AI, and then the AI is able to create images which look like you made it. What do you get for that? Absolutely nothing. And so that has raised many questions about where the lines are between fair use, imitation, parody, plagiarism, and so on. And questions like who owns the rights to your digital likeness? This is an influencer who posted some videos. The video, this is her talking about her experience. The video on the right was stolen and AI generated. In it, she's talking about her experience going through a divorce, and it was hijacked by an AI company and changed into an ad about sexual performance supplements, which is, ridiculous, but also unbelievably unethical. And what about after you die? Some of you may recognize George Carlin. Recently, a new video dropped, which was written by ChatGPT using his voice, but saying things that he never said, and his family was really upset about it because they were making political statements that he never would have made. So there are guardrails around protecting this. So AI, the reason you saw those examples of Mickey Mouse and stuff, is that there are guardrails which try and stop people from doing this sort of stuff, but they're really easy to circumvent. And if we have time during the Q&A, I can show you how easy that is. Well, I can't anymore because we locked out ChatGPT, but I can show you an example of where I did. Generative AI has huge amounts of content creation biases. So it was trained on data, and it tends to average out that data it was trained on. So, and you often see that in languages. So if you ask a question in English, you will get an answer which is in a similar perspective to what an average English person would talk about. And that's not just things for ethnic or cultural, but it can include anything: ancestry, religion, gender, disability, any minority group. It will talk about it often as someone who's not a member of that minority group, but it will pretend like it knows everything. Obviously in New Zealand, we have a unique circumstance around our indigenous population, Te Ao Māori, and one of the further complications about that is a lot of Māori history was verbal. It wasn't written down until European colonizers came and started writing the history, and then that got fed into AI. So when you ask AI in English about Māori, it's telling you from the perspective of English people who wrote about Māori rather than about Māori people writing about themselves. So there have been some naive solutions, attempts to solve this. So here is someone asking ChatGPT, I asked you to do something, you did something different, and it says, yeah, I added a bunch of words to try and add some diversity to it. So I added words like diverse, inclusive, specific ethnicities. But unfortunately, again, it's not in context, and what we ended up with is things like this, where you ask for an illustration of a 1943 German soldier, and it just injects words into your prompt, like woman, like Asian, like black. And of course, this was hugely offensive, and Google ended up having to make an apology for it, because they were like, oh, we didn't realize that people would kind of, take advantage of this. And of course, the solution to this is through appropriate consultation and approval. If you are writing stories or creating content about groups that you don't belong to, talk to someone who's from that group, even if you're using AI, to make sure that it is appropriate before you go through it. So finally, this has been a lot of negative publicity, I guess, about AI. Let's just finish it up with some possibly good things. Even though there are huge risks to the established entertainment industry, it does level the playing field for smaller companies, studios, and even individuals to create high-fidelity content. So here are some quotes from people who have vested interests in the AI entertainment industry, and they're saying things like, it democratizes content creation, it reduces the cost of creation down to zero, it offers an everyman alternative to heavyweights like George Lucas's founded Industrial Light and Magic. And Runway, who did the videos, the Cardboard Man and the Pirate Dog, have actually launched an AI film festival, which allows people with ideas to use AI to create films to tell their stories. And of course, that leads to new entertainment experiences as well. Things we can't even imagine might be possible when we have an AI which is able to create tailored experiences for us in a very short period of time. My final thoughts, it's only 9 minutes over. When I was writing kind of the description for this, I talked about, has Pandora's box been opened? Pandora's box, when it was opened, released all the evils to the world. But the other part of the story that other people don't talk about is the last thing that was left in the box after all the evils came out was hope. Storytelling is universal. It is and is as ancient as humankind. Before there was writing, there was storytelling. It occurs in every culture from every age. And if we really want to put a silver lining on the cloud, perhaps generative AI is just giving each and every one of us back our storytelling voices. Right, okay, sorry, that was a little bit over time. We will take some questions from our audience now. Do we have some stuff you can show, Bree?
lot of cats, actually.
Okay, there we go. Could I get you to drive these and maybe speak to them? So I can answer any questions if there are some. Are they just on ChatGPT?
They're on Suno.
On Suno.
These are Anthony's ones.
Okay,
I don't
all right.
know.
Well, we'll see if we can plug that in. Any questions?
Yeah, please. Because we said we were used to feed the AI data by choosing the motor or the food, and then we did that like a password process. But it will be judged by something if you have corrected enter or not. But if it knows already how to judge, how are we adding extra data to feed the AI?
So are you asking about the adversarial networks where you have the two AIs fighting each other?
No, I mean, ask us to recognize the traffic light or the motor.
Yep.
It would decide whether we correctly choose or not.
So great question. So if I understand what you're asking is, for the capture example where you're asked, select all the images of traffic lights, how does it know if you've done it correctly if it doesn't know what traffic lights is? So what it often does is, if there's, say, 3 images of traffic lights, 2 of them will be images that it knows are traffic lights, and then 1 of them will be something that it thinks might be a traffic light. So it can guess whether you're being honest or not, because you have to select the 2 it knows about, but then if you select the 3rd one, that's 1 additional piece of training data. So you might say, well, that's not a lot, but if you do that over billions of people, over billions of captures, you actually start to build up quite these large databases. So yeah, it's a very good question, one I considered talking about, but yeah, gets into levels of sort of how we can authenticate data and protect things around it. Thank you. Did you want to show anything? Any other questions? Sorry, you go. Any questions? Because Angeline's going to have to run around with a mic.
There's some music that was made based on some of the prompts. One of them was a cat playing the piano. And as you can see, the lyrics are mostly just meowing. And this is the kind of stuff you can get. You can put anything into it and get anything out. There's also one about gummy bears falling from the sky.
Gummy bears falling from the sky, sweet and sticky. Catch 'em with your eye, colors bouncing, falling all around through the sugar.
But it can do basically any single genre that you want.
Hold on, I'm trying to do document camera. Sorry, hopefully that will get you where you need to be. We're trying to do a low fidelity approach here, if we can figure out.
But it can do anything from like smooth jazz, which it can be instrumental or with lyrics. You've got heavy metal, there's drum and bass. You can do any genre that you want.
So there we go. Easy listening with a cat, tuxedo cat inside a piano for some reason. Cool. Any other questions? Otherwise we can just play you out with keyboard cat. Yes. Oh, 2 at the same time.
I'll go up first.
Are there any other images on there?
Hey, thanks. So, as general public, how do I know, how can I tell if something's AI generated, whether it's words, text, video, sound?
That is a very good question. Yeah, so the question was, and correct me if I'm wrong, how can we tell if something is AI generated or not?
Digital files, so, how do I know it's...
Yeah, absolutely. So if you remember when I was talking about these adversarial networks, the whole existence of them is predicated on being able to create things which are indistinguishable from reality. That's where the problem comes in. However, as much of it is a problem, it is also an opportunity, because as we're training our generative AIs to get better and better at creating fake things, we're also training our discriminators to get better and better at identifying AI-generated stuff. So there are a lot of tools which are coming out in the AI space now around detecting whether things have been generated in AI. Certainly as an educator, there is huge amounts of concern around things like academic integrity. How do we know students aren't using ChatGPT to write their essays? And so all of the academic integrity tools have AI detection things built into them now, which look for patterns in text, which tend to be a little bit more AI-like than perhaps human-like, because AI has a certain, like if you ask ChatGPT a question, it tends to always reply in a similar sort of way, and it's because of the way it's being trained on data. The caveat to that is that everything it's writing is actually valid English, so if you have someone who writes in a similar way to ChatGPT, it becomes really hard to know if they have actually breached academic integrity or whether it's just coincidence. And so that's why we're having to take a very sort of pragmatic approach of actually, we use it as an indicator, but it's not, we know you've used ChatGPT, it's over. We'll bring you in to talk to us face to face, so we're no longer in a digital thing, to actually find out whether you actually do know your stuff and you didn't just use ChatGPT to write it. So yeah, I guess the long answer to your question is there are some tools, the short answer is there are some tools, but everything needs to be taken with a grain of salt. It's just getting harder and harder to tell now. Thank you. I'm
really interested to explore ChatGPT a bit further around its data set. So it's my understanding, correct me if I'm wrong, or anybody correct me if I'm wrong, that it's hooked into the internet, or it's captured data from the internet to a certain point. Is that the case? And secondly, if it is it likely to go live in terms of data capture?
I laugh, I'll repeat the question. So the question was, ChatGPT is said to have been trained on the internet to a certain point in time. Do we know that's the case, or is it actually a live thing? And the reason I laugh when you said that is because, again, it was something I was thinking about adding to my talk, in that there's been numerous instances where it is spoken about things which happened after its cutoff date for the training, and then when you ask, how did you know that? It says, I didn't. My data actually ended back here. And so there is a huge amount of concern about whether it is actually being continually updated, and certainly the high levels of models, we had ChatGPT 3, then 3.5, and now 4, their end date on those data is increasing. In regards to will it go live, the Devon, the video that I unfortunately ran out of time to show, which was the software engineer, can literally jump onto Google and Google things it doesn't know and then absorb that data and then add it into its model. So I don't think it's a matter of if or when. Well, yeah, it is happening. Is it happening in ChatGPT? I don't know. Would they tell us if it was? I don't know. But yeah, it is something that we probably can assume that will happen if it's not already happening. Thanks. Yes?
For example, I take the image or the music and I produce it and sell it. Who owns the copyright?
Great question. Yes, so who owns the copyright to material that has been created? And that all depends on the server, sorry. So here we have Suno, and you'll notice here it has 2,360 credits with subscription. I actually paid out of my own pocket, not the university didn't fund this one, I did, for a paid license to this, because you have to have a paid license in order to use it for commercial usage, which technically this probably is, in which case if you use the free service, it belongs to them. If you use the paid service, it belongs to me. That brings up other ethical questions of if it's been trained on other people's data, so Bree writes a song and then it's trained on Bree's song, and then I create a thing which sounds exactly like Bree, I can take that and then use it for things, and Bree doesn't get any of the cut because the companies never pay the artists that they were trained on. So that is one of the ongoing sort of legal disputes in the AI world around actually paying the people who've made the content that your models have trained on. But again, the short answer to your question is the services often sell commercial licenses to it as part of your paid upgrade. So every time something's free, there's usually a paid version, which means that you own the rights to that content. Thank you. Time? Okay. Thank you all. Oh, sorry. I will hang around for a couple more questions afterwards. Sorry, we'll have to cut it short there because we're over time. Thank you all very much for coming to the talk tonight. I hope it was at least entertaining, if not interesting. Apologies, we got a bit rushed at the end there. If you do have any questions, I can hang around in the foyer to do some talk. Thank you all very much. Kia ora, and see you later.